My name is Tammy Miller. In this section of carbonyl nomenclature, we're going to learn how to name carbonyl-containing compounds. In this lesson, we'll be talking about the carbonyl-containing compounds of aldehydes and ketones. In aldehydes, we have a terminal carbonyl. What this means is the carbonyl carbon is the first one in the chain. It's on the end. This means it has at least one hydrogen attached to it. Because this aldehyde group is terminal, we usually do not need to include the number when we're talking about IUPAC naming. Aldehydes will have the suffix -al or -al for aldehyde. Aldehydes can have chains that are alkanes, alkenes, or alkynes. Ketones, on the other hand, have a carbonyl that is non-terminal. What this means is the carbonyl carbon is somewhere in the middle of the chain, meaning that it has at least one other carbon on each side of that carbonyl carbon. Due to the fact that it's in the middle of the chain, we're going to have to indicate the carbon number that the carbonyl is on when we're naming our ketones. Ketones have a suffix of -one, -one, for ketone. Just like aldehydes, ketones can have a chain that is either an alkane, an alkene, or an alkyne. With this information, let's go ahead and name a couple of carbonyl compounds. Our first carbonyl compound, what we want to look at is where the carbonyl carbon and oxygen are. And the carbonyl carbon and oxygen are right here. This means that they're at the end, and we always want to have the carbonyl on the lowest numbered carbon. So we're going to name this carbon number 1. So I have 1, 2, 3, 4, 5, 6. I have 6 carbons in this chain. So I know that this group is going to be a hex. Now, when I look at this, all the internal carbons have 2 hydrogens on it. So this means that this is a hexane. So I'm going to put an AN. And because that carbonyl carbon is carbon number 1 in the chain, I know that it is terminal. I know that this is an aldehyde. So I'm going to end this with AL. This is hexanal. For our second carbonyl carbon that we're looking at right here, we see that we have our carbonyl carbon and oxygen right here. On either side of that, there is at least one carbon. This tells me that this is going to be a ketone. I always want the carbonyl carbon to be on the lowest numbered oxygen. So for this one, I'm going to name it from right to left. I'm going to number 1, 2, 3, and 4. This tells me that this is a bute. Because there are 2 hydrogens on the third carbon and 3 hydrogens on each the first and the fourth carbon, I know that there are no double bonds. If we draw this out, this looks like this. And again, I know that this is going to be carbon 1, 2, 3, and 4. When I name this, I know that we are going to have a bute, butane, there are no double bonds, and then our ONE. To tell me that the carbonyl carbon is on the second carbon, I'm going to call this a 2-butanone. If we want to be very, very specific about this and very formal, we can also call this butan-2-one. Now, this second naming right here is a very, very formal naming. 2-butanone is just fine in most situations. For our third one, we see our carbonyl carbon very clearly in the picture. And I want that to be on the lowest numbered carbon. So I'm going to number this 1, 2, 3, 4, 5, and 6. This tells me that this is a hex. I do see a double bond, so I know that it is a hexene. Off of my fourth carbon, I have a methyl group. That substituent is going to be named first. So this is going to be a 4-methyl. My double bond is on the third carbon, so it's going to be a 3-hexene, and then 2-one. This tells me that the methyl is on the fourth carbon, the alkene is on the third carbon, and the ketone is the second carbon. Again, we have another way of naming this that is very, very formal, and that would be 4-methyl hex 3-ene. So we're specifically telling ourselves where the alkene is. We do that on the first one as well. So we have 4-methyl hex 3-ene 2-one. Again, this second one is a very, very formal way of naming. For our final one, we see that our carbonyl is on the terminal carbon. This means that this is carbon number 1. So this is going to be an aldehyde. Then we have carbon number 2, 3, 4, 5, 6, 7, and 8. So this is going to be an oct. And because of the triple bond, it's going to be an octyne, Y-N-E, and it's an aldehyde. So this is going to be an octanol. We have to look at our substituents that are here. We have an isopropyl on our 5th carbon and a methyl on our 6th carbon. As always, these are going to be named in alphabetical order. So I'm going to have 5-isopropyl 6-methyl. My triple bond is on the 3rd carbon, so this is going to be a 3-octynol. So I'm going to have a 5-isopropyl 6-methyl 3-octynol. If we want to be incredibly formal, we can, again, rearrange this. So the 3 is by the ine and get 5-isopropyl 6-methyl oct 3-ine al, telling us that, again, that triple bond is on the 3rd carbon. When we look at this, the less formal is the commonly used nomenclature. The more formal is something that some of our professors, some papers when they're written, are very, very formal with this. So know how to name both the incredibly formal as well as the more common IUPAC names.